In this video, we're going to look at the law of cosines. We are going to just take a look at two examples of the side angle side variety. On some worksheets, I give more examples than this, but I'm only going to do these two for this page because I feel the rest are redundant. And the last problem I'm going to do is going to have kind of a neat little twist to it, something you should see with the law of cosines. Alright, so first of all, you'll note that I'm not given a triangle. I'm just given two sides and an angle. And to make sure that this isn't the side-side angle situation like in the law of sines, I should draw a picture of it. Now, I'm not going to bother by drawing the picture to scale. I'm just going to draw the picture, or as I like to call it, drawing the Dorito. So I'm just going to draw a triangle. I'm not going to care about the size of each angle or side, and I'm just going to label my vertices as capital letters in clockwise formation. That would mean that the side across from those angles are going to be the side lengths. So across from angle A is side A. Angle B is 10 degrees here, this little arc, and side C is across from angle C, so this is going to be 1. So this gives me the side angle side variety that I have to solve with the law of cosines, because the law of sines would require me to have a side across from an angle, and I don't. So I'm going to have to find side B here, and once I find sine B, I'm going to find angle A, and then I can easily find angle C. So those are my missing pieces. I am missing B, which I'm going to find first, then I'm going to find angle A, and then I can easily find angle C. So let's start off with the law of cosines. So for B, it starts off like the Pythagorean theorem. B squared equals A squared plus C squared, except that I'm starting with B instead of the usual A. I am then going to subtract minus 2AC times the cosine of, put my time symbol there, times the cosine of B. Now I'm going to plug in what I know and solve for B. So my A is given, the letter C is also given, these are my side lengths, and I get to use that again here and here. And I do know my angle for B, so here's my algebra. Now let's do a little simplification. 2 squared plus 1 squared is 4 plus 1, which is 5. And 2 times 1 is 4, cosine of 10. And this is another situation where I want you to not fall into a common mistake and say 5 minus 4 is 1. If this was 5 minus 4x, you wouldn't call that 1x, would you? So that cosine of 10 cannot be combined with the 5. So what we have to do is type this into the calculator. Thanks to order of operations, the calculator will multiply these first and then subtract that from the 5. So B squared is equal to approximately, checking notes, let's see here, 1.06. Sorry, it took me a second to find my notes. And then we take the square root of both sides, and we do not have to worry about the negative. So 1.03 is what you get for that. So B is equal to 1.03. 1.03. Now we should check to find angle A. Now, when I'm finding angle A, it's very important that I don't use the law of sines. I know you might be tempted because now you have your angle of angle B and side B, so law of sines would work, except this is going to give you a two solution, or the ambiguous case, because you're choosing a side, and an angle. Do not use the law of sines after you use the law of cosines. You're destined to get into trouble. So what I would do instead is I would try to find angle A using the law of cosines. So we start with A squared equals B squared plus C squared minus 2BC cosine A. And we're going to again find the angle A here, so let's plug in what we know. 2 squared equals our newly found side B plus side C, which was given, minus 2 times our newly found B and side C cosine A, which we don't know. So this is 2 squared or 4. Probably should save a little bit of room here since I'm running low. So 4 is equal to 1.03 squared plus 1 squared is 2.06 minus 2 times 1.03 times 1 is 2.06 cosine A, which again, you can get into trouble if you think this is 0 and 4 is not equal to 0. You have to subtract the 2.06 from both sides. Don't factor out a 2.06. It's not going to put you in a better place. So 4 minus 2.06 is going to be our 1.94. So our 1 and 94 hundredths is equal to negative 2 and 6 hundredths cosine A divided by negative 2.06. Now, are you a little nervous to have a negative divided by positive? It gives you a negative answer. It gives you a negative 0.94 equals cosine of A. Well, that's going to give you an obtuse angle. If you take the inverse cosine of both sides, which gives you A on the right-hand side, the inverse cosine of negative 0.94, typing that into the calculator, is 160.4 degrees. So our angle A is obtuse, 160.4 degrees. And now you can see why taking the law of cosines was safer than taking the law of sines, because you could have had an ambiguous case here. So I've got my 104 for my A, or 160.4 for angle A, and now I can use simple subtraction to get angle C. 180 minus 160.4 minus 10. That is going to give me my final answer, which is a mere 9.6 degrees. And there you go. There's my answer to the problem. And there are all my missing sides and missing angles found. So for our final example here, we're having another example of side angle side. And we are going to take a look at this problem. Again, since I'm not given a picture, I'm just going to make A and B and C with no specific shape or dimension. Angle A is across from side A, so here's my 3. Angle C is across from side C, so here's my 2. And angle B is right there at the corner, and wait a second, 90 degrees? Well, this is a right triangle. In right triangles, we can use SOHCAHTOA, and we can use Pythagorean theorem. But let's just humor this problem for a little bit here, and let's just kind of solve it using the law of cosines. And mark my words, if you actually find a problem like this on any assessment, you don't have to use a specific method. It's use the best method. But let's just try to use a law of cosines and see what happens, right? So we're going to find missing side B, just like we did on the problem that we just finished. So B squared is equal to A squared plus C squared minus 2AC cosine B. Okay, so let's plug in what we know. Well, we don't know side B, but we do know everything else. 3 squared plus 2 squared is my A squared and C, A and C respectively, minus 2AC cosine of 90 degrees. Okay, so now I have B squared is equal to 13, because that is what you get when you have 9 plus 4. Now all of this here is going to be 12 cosine 90, or 0, because the cosine of 90 degrees is 0. That's kind of nice, right? And it kind of makes sense, but isn't that, if you kind of look at this now, this is just the Pythagorean theorem, taking two sides and finding the third side. But check it out, that's what happens when you get a triangle like this. So the B is going to be the square root of 13, or approximately 3.61. So here's my B is equal to 3.61. Okay, now what I'm going to do is I'm going to, off to the side here, make a proper right triangle. Okay, as good as I can freehand a right triangle. Humor me there. So this 3.61 is what was across from the 90 degree angle. Let's go with angle A at the top here, and angle A is going to be across from side 3, and then we have side 2 right there. There's 2, because that is going to be my C right there. Okay, so I know we could use this right triangle to find all the missing sides and all the missing parts and pieces of this problem, but instead of doing that, let's just use the law of cosines again. And so if we use the law of cosines, let's try to find angle A. Let's try to find angle A. So we're going to go A squared is equal to B squared plus C squared minus 2BC cosine big letter A. All right, now again, we don't know this angle measurement right here, but we do know everything else. We do know that my A squared is going to be 3 squared, right? We also note that the newly found B is 3.61 squared plus C squared in this case, which is going to be our 2 squared minus 2 times 3.61 times 2 cosine unknown angle A. So now we have 9 is equal to the 3.61 squared plus the 2 squared is 7 3/100 minus the 2.61 times the 2. This gives me 14.44 cosine A. So we subtract our 17.03 from both sides. Sorry, pen slip there. So those simplify, and what this does, it gives me an answer. 9 minus 17.07 is negative 8.03, or 8 3/100, and that's equal to negative 14.44 cosine A. And if I now divide both sides by negative 14.44, what that gives me is cosine A on the right-hand side, and on the left-hand side we have 0.56. And if we then take the inverse cosine of both sides, by taking the inverse cosine, we now have A left, and the inverse cosine of 0.56 is coincidentally 56.2 degrees. So it looks like angle A is 56.02 degrees, which is pretty nice. And then what we're going to do is we are going to take the missing side here, or missing angle here, and subtract from 180. So 180 minus 90 minus 56.02 is 33 point, let's see, 56.2. I think I put 02 there. But anyway, sorry it's a little messy. 33.8 degrees. Now again, knowing that it's a right triangle, we could have done something simple for angle A, because we know that the tangent of A is equal to the relationship of opposite over adjacent. So if this is our theta right there, our opposite side according to theta is 3. And our adjacent side according to theta is 2. So that's opposite over adjacent. Opposite over adjacent. So if I take the inverse tangent of both sides, I now have A is equal to the inverse tangent of 1.5, or 3/2, and that gives me an answer of 56.3. Again, I'm pretty close to the actual answer, and that's kind of what we're showing here, is that you can use the law of cosines on a right triangle if you want to. Of course, knowing the trigonometry for the right triangle can be a lot faster.